extra examples from 6.2, apples, the sum of random variables. So suppose that the weights of a certain variety of apples have weights that are approximately normally distributed with mean 9 ounces and standard deviation 1.5 ounces. If bags of apples are filled by randomly selecting 12 apples, what's the probability that the sum of the weights of the 12 apples is less than 100 ounces? So we are going to define our random variable. So as part of our state, we're going to just define our random variable to be the weight of a randomly selected apple. So let x equal the weight of randomly, so this is how I want you to do a state plan do conclude on a test or homework. Weight of randomly selected apple, and then the total. We'll have a new random variable that's the total, where we add up each of the apple weights, x sub 1, x sub 2, all the way to x sub 12. So our goal then is to just find the probability that the total is less than 100. Find the probability the total weight after adding those 12 apples is less than 100 ounces. So we need to know the mean and standard deviation, and then since the apples have weights that are approximately normally distributed, the distribution of the sum will also be normal, have a normal distribution. So we can use our, we'll be able to use normal CDF on our calculator. So the expected value of the total is just the sum of the averages of each apple weight. So mu x sub 1, mu x sub 2, etc. This is, I'm just kind of doing it all. This is the do. This would be the do. Yeah. Mu sub x for the 12th apple. You would just add up the weight of each apple. So 108 ounces. So that's the mean that we're using. For the variance, sigma squared, you would just add, you would take the standard deviation and square it, so you would have the variance for each apple, and you would just add those together, etc. So remember the formula we wrote down, that the variance of the sum is equal to just adding the individual variances. So that should give you 27. And then, so the standard deviation of the total is the square root of 27, which is about 5.2 ounces. So we just want to know the probability that the total is less than 100. So the fastest way is to, on your calculator, go to normal CDF, which is under second vars. Normal CDF. We want less than 100, so enter some really small number. That's the lower bound. The upper bound is 100. The mean we're going to use is 108. The standard deviation of the total is going to be 5.2. And you should get about 0.0620, and then your conclusion would be, so there is a 6.2% chance that the 12 randomly selected apples have a total weight less than 100. 6.2% chance.